software, and we're going to run it with 3 trains for now. We'll put the first on green, we're going to put the second on green line, and we'll put the third on the red line. So here is the central CTC. As you can see, the first train has already been prepared to dispatch with its authority, suggested speed, and whatnot being calculated. All of this has been automatically loaded in from a schedule, and it's already hit its dispatch time, so we can go ahead and dispatch that. Once dispatched, the train will begin moving, and this shows the occupancy, signifying that it's starting to move along these blocks. If we go into train 1, we can see that it is indeed moving, and we can see that its destination is Overbrook, so it'll go all the way around the track, all the way to Overbrook. Should we just let it hang out? As you can see, our second train just actually updated and had some calculations done for suggested speed, and that's because it hit its dispatch time from the schedule. So now we can also go to the second train, and just letting this one get a little bit further, and we can turn off the surface brake and launch it. As we can see, it gets some velocity and it's moving. Now it might get a little fast, and if it gets too fast, it should stop because this train's already here. But either way, those guys are moving. And up here we can see block info pane, and this will tell us some information about status, whether there's a crossing or whatever light color is there, and you can also set blocks to maintenance mode. And I'm going to revisit this in a little bit. Additionally, you can see ticket sales based on station. And go through. These are updated dynamically. So these trains are just going to keep running until they reach their destination. We can go over to the red line, and we can do some manual mode dispatching for our third train. So this is currently displaying the metrics for the first train. If we switch it to the third train, we can turn manual mode on. The system status pane shows you some helpful information about kind of what's going on and what you need to do. You can select a manual path. So our train's in yard, so we're going to give it a path by selecting the blocks we would like it to travel on. We'll just send it to Heron Ave for now. Sorry, misclicking this. If you click the block again, it'll just deselect and remove it from the path. We just submitted that path, and it's a successful path, and it calculates the authority and gets some speed limit information and the destination. Now we can set an arrival time by clicking enter there. So we'll set 13:04, so it should have plenty of time to get there, and we'll press dispatch. This shows us that it's a valid dispatch. It has calculated suggested speed, and it calculates suggested speed dynamically based on authority, how much time the train has to get there from when you're dispatching, and speed limits. So now that all of that has been done, we can go ahead and train 3 should be ready to dispatch. So we can take off the brake, put it in automatic mode. And as you can see, it'll start speeding up, and we're getting the authority, and it will start moving. So that's going to start moving towards its destination. Everything's good there. We can switch back over to our green, and we can actually see, like the case that I mentioned earlier, this train actually got a little too speedy and caught up to the other one, it seems. So it saw that that block front was occupied, it stopped itself. Now, right now, we're just going to do a demonstration of setting a block for maintenance mode. We're going to go ahead and set block 67 for maintenance. We have a train running right now. As you can see, it's now indicated that it's in maintenance mode. Now, if we go and check the block in the track model. We can see that the broken rail / maintenance mode has now been set. And as we watch, this train's going to get to that block, or get to the block before the block set to maintenance mode, and we'll get to see it slow down and stop in just a second. As you can see, and realize that the next block is in maintenance mode, and it immediately begins to slow down, and it'll come to a complete stop. And that's maintenance mode for the blocks on the CTC.
Alright, hello. I'm going to be demonstrating the functionality of the wayside controller. We're going to choose software, 2 trains, one on green, one on red. This will initialize 2 trains, one on the green yard and one on the red yard. One here and one here. From my wayside UI, we're able to see if the train is in maintenance mode, which is currently not, which will be set by the CTC. We can check the data for the waysides that are instantiated. So there are currently 2 waysides instantiated, or running, as there are 2 trains. The first and the second. And you can see that there's data populated for each of them, but if we go to wayside 3, there's no data, as there's not a 3rd wayside. Then we can also go to the PLC menu. This shows what file is currently running for the waysides that are up and that are being used. If we look at the wayside 1, which should be the one related to the first train, we will see a PLC-G, which means it's on green line, -yard decay, which describes the file that's running. Secondly, if we go to the one on the red, we can see it is PLC-R, which is for red line, -yard to C, which describes this connection. If we start the PLC, or start the train on the green line, we'll see that data populates for that wayside. You can see that here. And this is all the data that it's taking in and giving out to the modules that it's connected to. As you can see, there's commanded speed, commanded authority, speed limit, any failure states that it might register, gates and crossing lights, which will be explained later. The switch position of the PLC, or each wayside has one switch, so it's the switch position for that wayside. Track occupancy, which is of its current block, and next in path occupancy, meaning that there's no trains currently hindering the traversal of this train. Then we get in suggested fee from the CC, suggested authority from the CTC, which is for a total path, the speed limit of the block, if maintenance mode is true, and then track presence again, and any failure modes.
Hello, I am Tyler Scheinberg, and I will be demonstrating the functionality of the track model. Running the simulation, we will be selecting 0 for software, and we will be running with 2 trains, the first train being placed on the green line and the second train being placed on the red line. And right away, we will dispatch this train and allow it to start moving. And we can see that the train has left the yard and is heading towards Glenbury. Moving over to the track model UI, there is a variety of options for functionalities you can do. You can add a track piece, allowing you to select what kind of track piece, the line, the section, and the size, and adding this component will add it to the track model. Inspecting the circuit use, this includes both the green and the red line, which are both loaded by default when the system is run. You can cycle through the different blocks, either by selecting next or previous, which will access the next or previous block sequentially by ID, or you can search for a specific one, such as green 57, and that will pull up green's block with the ID of 57. Next, we will be inspecting for track presence. The block is heading towards 67. Now opening up the menu, we will search for block 67. And it has not entered it yet. The previous block is occupied where it is, and it reflects the data that is being passed all the way to the CTC. As you can see now, the train has left this block, and it has now entered block 67.
Hi everyone, I'm Ling. I'll be demonstrating the train model. So we're gonna start. We're gonna use software for this demonstration, and we're just gonna use 2 trains, both one on the green line and one on the red line. So as you can see, each of the trains have their own train model window, and they're both labeled to the corresponding train. Right now we're going to focus on train 1, and we're just going to pull up the CTC to see where it is at. So right now it's in the yard. This is the train model window. Right now everything is initialized to 0, at least the velocity, acceleration, and power, because it hasn't been started yet. There's the train parameters here. There's no passengers yet, but there's 2 crew have already come onto the train to prepare for passengers, and also displays the ID that matches the window name and has the outdoor lights here as well. In the car information, you can select 1 through 5 cars. Each of them will display the temperature, the lights, and the door state. The temperature you can change to however you like, and that'll just be implemented in that car. And the train controller demonstration will show you the toggling of the lights and doors. So let's start this train. We're gonna go to the corresponding train controller and do automatic mode. You'll see that once power is started, it'll start calculating velocity and acceleration. And we're just gonna wait until it gets to Glenberry so you can see that some passengers get on. All right, you see that we are at Glenberry, and if we go back to the train information, we have 120 passengers now, which is corresponding to the ticket sales on the CTC. And just to demonstrate, I will stop the train with the emergency brake, and this is for the passenger to use, and it'll start decelerating, and it'll stop decelerating when the velocity is at 0. forward. All right, so to restart the train, we disengage the emergency brake from the train controller and we activate automatic mode again, and now it's going again. So I will demonstrate now the train engine failure, which will receive no power from the train controller, even though it would still be in automatic mode, sending 85,000. And as you can see, there's no longer any power, and the train recognizes this and no longer accelerates. So from the train controller, it would have to stop the train, and once the train is stopped, you can disengage the messenger brake and the failure would be fixed. And you can start the train again. For signal pickup, if you click the failure mode, you would receive an invalid authority, and the train would stop on its own. You can see that the emergency brake was automatically disengaged. Well, engaged, and then you would disengage it, and you can start the train again through automatic mode, and you can see that the failure has been fixed. And now demonstrating the brake failure, if I click this, and then you can see that if I click emergency brake, it does not decelerate at all. I can try to turn the service brake on, and it also does not decelerate. And I can try it from the emergency brake on the passenger side, and it's still going. And that is the demonstration for train model. Thank you.
All right, I'm Greg Wagonblast, and this is the test for the train controller software. So you can see I'm entering 0 for software. We'll test 2 trains, first on the green line and the second on the red line. Let's pull up the CTC window so we can see where the train is. And we'll look at the first train on the green line. So we can see we have train 1 in the train model. And if we go to the additional information page, we can see the corresponding train ID number, train 1. All the other values are initialized right now. Nothing is updating because we have not dispatched a train. We have all our driver functionalities up here under driver. Emergency brake is accessible to everyone. Utilities down in the middle and engineering at the bottom. So for announcement, we're currently in the yard and we have no station. Let's see toggling of the indoor and outdoor lights. We can do the outdoor first. You can see this updates on the train. Same for the indoor lights. Okay. And since the train is not running right now, we can also open the doors and close the doors. So that's utilities. Now we can dispatch a train and we'll send a constant power out of 8,500 watts. You can see that the train is on the move. And that the train controller is responding to velocity it's receiving. Now, if the engineer wants to input some KP and KI and control the desired velocity, all he has to do is enter a numerical value hit enter on his keyboard. Let's disengage automatic mode. And enter the desired velocity. So we can see that we're accelerating now towards that velocity. The power has changed. And this is also for the corresponding train. So other than that, the driver also has the ability to control the braking. We can see the service brake went to the middle of the bar here. We're decelerating. You can also turn it off. I turned it off before the train stopped, so we're going to accelerate back up to our desired velocity. The emergency brake has similar functionality, although the slider will go all the way to the end to indicate an emergency brake was pressed, and we accelerate much faster. Now I turned that off very quickly so we can continue accelerating. So the driver has control over all that. Everyone has control over the emergency brake. We have the same functionality with the emergency brake and the additional information window. And as for safety critical architecture, there is a redundancy check implemented. 3 proportional integral controllers were instantiated, and we check between all those PI controllers to make sure the power is the same before we pass the power to the train model. As for a diversity check, we have the trapezoidal rule, and we also use the right hand and left hand rule to achieve the same functionality. And we check between those powers, and if the powers are the same, then we're good to go to send power. Now, for the last test, we'll wait to see the train get near 20 miles per hour so that we can see that the train responds to a cap on velocity so that we don't exceed the desired velocity. We also wouldn't exceed the speed limit. And when we get to a station, the train will come to a stop. But we'll see this stuff end when we get to our final destination further on in the demonstration. So I think that covers most of what I wanted to demonstrate. And we'll look at the other modules before we connect to some of the final tests. Okay, thank you for your time.
This will be a demonstration of the traffic light signal and crossing working. We're going to start with the train 2 blocks away from the crossing at block 19. We will start the train heading in the direction of block 19. You'll see currently that in the wayside for that area, the crossing light and the gate activation are set to 0. When the train enters the block before the crossing, the light will turn to 1, which is an indication that the light is yellow. When the train reaches block 19, which is the actual crossing itself, you'll see the gate be set to 1, meaning that it is closed, and the railway crossing light be set to 2, which is an indication that is red. And we will just wait to see that happen. There you can see the railway crossing light has gone to 1, meaning that it is 1 block away from the crossing, meaning that it is yellow. Also just to prove that the train is moving. Now you can see the railway crossing to light is 2, which means it's red and it's currently on the crossing, and the gate is 1, meaning that it is closed. And in the next block, the gate should open, and the crossing light will go back to 1. And when it leaves this next block, the crossing light will go back to 0. And you can see that it's exhibited there. Thank you.